We have a circuit here, and each with 3 branches. Each branch has a cell and a resistance. So let the EMFs of the cells be E1, E2 and E3, and the resistances be R1, R2, R3. Solving a circuit problem for currents is a matter of solving simultaneous equations, and with 3 branches you will have 3 currents, and junction rule gives relation to 3 currents, and then you try to loop equations. That will be a little bit tedious. Let's try it out a little differently. There are 2 junctions here. Let's say one of the junctions is at 0 potential. We could choose any one of the junctions is at 0 potential in a circuit. Let the potential here be V1. Since there is a drop in potential V1 across the cell, this potential here would be V1 minus E1. And the potential here, there is a drop in potential V2 here, this is V1, this is V1 minus E2. And this is V1 minus E3. So we know the potential difference of each resistance. This is V1 minus E1 and this is 0. This is V1 minus E2 and this is 0. So V1 minus E3 and 0. So we know the potential difference of all the resistances. Just for the sake of symmetry, let's assume currents are all towards this junction. They couldn't be. Well, all the currents cannot be towards junction. At least one of them must be away from the junction. But let's assume that, and on solving, one of the currents will turn out to be negative. So current through this resistance will be V1 minus E1 by R1. We are applying Ohm's law here. V1 minus E1 by R1. And the second one, the middle branch, is V1 minus E2 by R2. And the lower branch, that is V1 minus E3 by R3. This must be equal to 0. Some of the currents arriving at this junction must be 0. Obviously one of them must be negative. This V1 will be smaller than the largest of the EMFs and greater than the smallest of the E's. Anyway, that the equations will take care, and sorting things out, V1 into 1 by R1 plus 1 by R2 plus 1 by R3 equals E1 by R1 plus E2 by R2 plus E3 by R3. So V1 will work out to be E1 by R1 plus E2 by R2 plus E3 by R3 divided by 1 by R1 plus 1 by R2 plus 1 by R3. So once you got V1, you can find the currents in individual branches. So it's become simpler because instead of 2 currents, I1, I2, and I3 would be I1 plus I2. So well, at least 2 simultaneous equations you have to solve, and this makes it a little easier. That with labels, no values. If it were values, 2 simultaneous equations are not a problem, but with labels it becomes really hard. One interesting situation here is if E1 equals E2 equals E3. So let's say E comes out and V1 will be equal to E. So if this is E and this is E, this will be 0, 0, 0. No current in any of the branches. So if all the cells are of equal EMF, there will be no current in any of the branches. That's an interesting result. So anyway, this is a nice, way of solving for circuits, assuming potentials rather than assuming currents. Once you got the potentials, you can go back and find the current in each of the branches. This current is V1 minus E1 by R1, and so on and so forth.